All right, we're going to go through the Chapter 10 and 11A Deeper Investigation Worksheet. Some of these are on the study guide, and you can skip those in the study guide when you get to that point, but you're going to want to turn in these notes as well. Anyway, I know it's a little bit blurry, but I think you'll be able to see it here. An observer on a sea cliff with a height of 12 meters spots an otter through a pair of binoculars at an angle of depression of 5.7 degrees. How far is the otter from the base of the cliff? Make sure to include a sketch. All right, well, let's draw a sketch. He's 12 meters high, and it's an angle of depression of 5.7 meters down to the Mr. Sea Otter here. How far is this distance from the otter to the base of the cliff? Okay, so we can simply use the tangent function. Remember alternate interior angles. This angle is going to be the same as this. So tangent of 5.7 is going to be opposite over adjacent, so 12 over x. So x is going to be 12 over 5, tangent of 5.7. X is equal to approximately 120.224 meters. Okay. Now, take a look at part B of this question. 5 minutes later, the observer spots the same otter at an angle of depression of 7.6 degrees. How much closer has the otter moved to the base of the cliff? Make sure to include a sketch. So now we're still 12 meters above, but now the angle of depression is 7.6. So here, 12 over what I called y. Tangent of 7.6 is opposite over adjacent, 12 over y. Y is equal to 12 over tangent of 7.6. Y is approximately 89.936 meters. So from the previous slide, x minus y is equal to approximately 30.288 meters closer to shore now. Okay, continuing on. Two cars leave from the same point in San Jose at the same time and travel along straight highways that differ by 27 degrees. If their speeds are 52 miles per hour and 44 miles per hour respectively, determine how far the cars are apart after 45 minutes. Round your answer to 3 decimal places. Make sure to include a sketch. Okay, well, let's draw a sketch. Two drivers going in 2 different directions that differ by 27 degrees. I'm going to call this driver A and this driver B. And C is how far apart are they. So let's take a look. A, he travels for 45 minutes or 0.75 hours at 44 miles per hour. So A is going to be 33 miles. B, 52 miles per hour for 3/4 of an hour, 0.75 hours, equals 39 miles. So now I know what A is, I know what B is, I know what this angle is. I can use my law of cosines to figure out what C is. C is equal to the square root of A squared plus B squared minus 2AB cosine of angle C, which is 27 degrees. So if I plug that into my calculator, I've got 33 squared plus 39 squared minus 2 times 33 times 39 times cosine of 27 degrees. Take the square root of all that. C is approximately 17.792 miles, which makes pretty good sense, I think. So you might want to check those on your calculator. Make sure you know how to do those. All right. Take a look at number 3. 3 ships are at sea, the Admiral, the Barstow, and the Caldrew. The crew on the Admiral can see both the Barstow and the Caldrew. They measure the angle between the line of sight to the Barstow and the line of sight to the Cauldron as 49 degrees. They radio the Barstow and by comparing known landmarks, find that the distance between the Admiral and the Barstow is 472 meters. The Barstow reports that an angle of 63 degrees is found between their line of sight to the Admiral and their line of sight to the Cauldron. To the nearest meter, what is the distance between the Barstow and the Cauldron? So let's take a look at what we've got here. So they're conveniently start with A, B, and C. So we'll use that. The Admiral says that between the Cauldron and the Barstow is a 49-degree angle. On the Barstow, between the Admiral and the Cauldron, they say they have a 63-degree angle. And we know that between the Admiral and the Barstow is 472 meters. So we'll call that side C. Well, what do we have? We can use the law of sines. Okay, sine of A is to A as sine of C is to side C. Well, what is the angle C? Well, it's 180 minus the sum of the other two gives us 68 degrees for angle C. So now we can plug that in. Sine of 49 is the side of A as sine of 68 degrees is to 472 meters. Now rearranging, A is equal to sine of 49 times 472 divided by sine of 68 degrees. If you plug that into your calculator, you'll come up with 384 meters, which sounds reasonable. All right, finally, we'll take a look at number 4. Sketch the graphs of f of x equals sine of x, g of x equals sine of 2x, and h of x is equal to negative 2 sine of x on the same coordinate axes. Identify the amplitude and period of each graph. In complete sentences, describe how g of x and h of x are similar and different from f of x. So let's take a look at what we've got here. I've got my regular f of x equals sine of x. That's in the purple here. It's got a period of 2 pi. It's got an amplitude of 1. Well, my g of x equals sine of 2x. My period is pi. The amplitude is still 1. So it's in blue here. G of x is in blue. And h of x is negative 2 sine of x. Well, it's going to be flipped over the x-axis, and its amplitude is still 2, but its period is still 2 pi. So g of x and f of x have the same amplitude but different periods. There's twice as many cycles of g of x in the same space as f of x. H of x has the same period as f of x, but an amplitude of 2, and it's reflected over the x-axis. So I'll leave this up here for a little bit. You can take a screenshot if you need to and copy this all down. I know that's a lot of writing and drawing there, but you can see that. And you can also check the answers on the study guide for more information. So again, you can come back to this. I'll just give you I'll wrap this up, and then you can come back and look at it if you need to. So that's where we're going to stop for today. So again, if you see these same questions in the study guide, you can skip those in the study guide. You don't have to do them twice. So, but I do want you to turn in these notes. So, all right, that's where I'm going to stop.